Oh, it's time to start. We're a bit late. Dear audience, I'm very happy that so many logicians are interested in the debate about the role of logic in AI. Let me start with a little introduction and the reason we have been organized this debate. My name is Tomasz Jarmużek. I'm a logician from NCU. This is my colleague, Łukasz Mikulski. He's a computer scientist, NCU. So the idea is that I'd like to present the main reason why we have organized this meeting and why we gathered and invited so many excellent researchers, knowers, logic and AI at the same time. I would like to present some logical point of view, my point of view. As you know, logic is of transforming symbols. This is the I think, good definition of logic, of principles for transforming symbols. This is what the old-fashioned AI was, transforming symbols. But new AI is something different. It is about sub-symbolic processes. Some people say that it is not clear how it works. There are some social fears. This is not about that. I will give some practical reason. I'm worrying if we, logicians, will in the future have a job. If there will be no symbolic AI, what will be our main activity in the new world? But some people give us the hope. This is, for example, Łukasz, and I hope that some of the specialists will share this hope, that we are waiting for some turning point, that new AI will have to include some old methods. So the methods of new AI will be mixed with symbolic and some symbolic methods, which I think is a good news for logicians. I am curious if my hope is really shared by the experts. This is my reason for organizing this meeting. Let me give the microphone to
Okay, thank you, Tomasz. So for this introduction of the topic and the reason why we are gathering here, I would like to say a few words about our panelists. First of all, one of them is online. This is Professor Rajiv Gore. It's Professor of Computer Science in Monash University. He's an expert in non-classical logic and automated deduction. His research spans proof theory, model and substructural logics, and the computational aspects. He has contributed significantly to the development of the logic-based tools and underpinned formal verification and intelligent reasoning system. This is Rajiv Gore. Maybe welcome him. Okay, our second panelist is Professor Wojciech Jamroga. He's Professor of Computer Science, Polish Academy of Science and Nicolaus Copernicus University in Toruń. He specializes in logic for multi-agent systems, particularly temporal and strategic reasoning. His work explores how agents can reason about actions, knowledge, and goals, key components in the development of intelligent systems with explainable decision-making capabilities. Let's welcome him warmly. Our third panelist is Professor Damian Iwiński. He's Professor of Computer Science in University of Warsaw. He's known for his foundational work in formal methods, automata theory, and logic in computer science. His research has contributed to our understanding of the limits of computation and verification, offering insights that are crucial both in theory and practice of reliable AI systems. Let's next panelist is Professor Marek Sergot. He's Emeritus Professor of Logic and Artificial Intelligence in Imperial College London. He's a pioneer in the application of logic to AI, especially in legal reasoning and normative systems. His seminal work on logic programming and formal representation of laws has paved the way for rule-based AI and reasoning about institutional process in both human and artificial agents. And last but not least, our fifth panelist is Professor Josef Orban. He's researcher in automated reasoning and machine learning in Czech Technical University in Prague. He's a leading figure in the intersection of automated reasoning and machine learning. His work focused on combining deep learning with logical inference systems, particularly in large formal mathematical libraries. He's known for advancing the automation of theorem proving and for bridging formal logic with practical AI applications. Okay. So now we'll go to the discussion part. We have prepared 5 topics and we will ask our panelists to say something about them, but we also have a lot of time for this discussion, and we hope that there will be much time for the question from audience at the end. So let's start. Maybe let's with the first question. Yeah. So the question is, what are the limitations of classical logic when applied to complex AI decision-making processes? And I will ask Professor Gore to start the discussion.
Me?
Yep.
Is that, you want me to speak?
Yes, yes, please.
Yep. Okay, sure. So, but I think that the biggest problem or the limitation of classical logic that we'll have is simply its expressive power, right? That pretty much. Can you hear me, Łukasz?
Yes, yes, we can hear you. Yes, yes.
Yeah, okay. So I think that, you know, even the simplest decision-making processes require some sort of, you know, non-classical modalities in some way. And I can't really see any way that, you know, good old material implication is going to do the job, so to speak, right? That's all I have as far as that is concerned.
Okay, so thank you. So let's go further. I will ask Professor Jamroga. Continue.
Okay, so maybe my statement would be much more radical. I would say that neither classical nor non-classical logic is extremely good at decision-making processes. And if you think of the history of symbolic AI, let's say the 70s, the shaky robots, so these were the attempts to use formal logic to implement decision-making, and the outcomes were, well, it was basically a robot who that could stand in one place and shake in the attempt to make any decision what to do in the next step. So then a lot of interesting research came out from that in logic and computer science, trying to define and overcome the frame problem and so on. But in terms of getting formal logic to provide working solutions, I don't think there has been much success. So in this sense, I think logic is simply not so good at providing implementations of decision-making processes, neither in the symbolic paradigm or now. I mean, we are, in a sense, we are not in a worse situation than we used to be. AI solutions are working much better, but still, okay. Let me, I don't want to steal the whole discussion. Let me summarize that, in my opinion, logic is not extremely good at providing working solutions. Its role around AI and within AI should be in another place. But now I'm passing on the baton to Damian.
Yeah. Okay, so
Yes, please continue.
so my point of view is somewhat opposite. Because I would say that classical logic is enough and all the rest is just syntactic sugar. Well, but of course it depends on how we understand these terms classical logic, because we can understand them in a narrow or in a large sense. Thomas said yes, that logic is the theory of symbols. Yes, my view is that the logic is theory of truth. And in this sense, if you think that it's a theory of truth that is based on mathematical methods, I think that it encompasses all approaches, yes, including temporal logic, modal logic, intuitionistic logic, and so on. But we can understand logic in some more narrow sense as some element of programming language, yes, but we program some interaction. So it may be profitable to use some elements of modal logic or fuzzy logic or some specific logics. But from a theoretical point of view, I think all this can be interpreted in classical logic and in set theory. But on the other hand, the logic evolves, and there are logic as science evolves, and there are some interesting concepts. This morning, some of you could have this concept of supervenience logic by Johan van Bentem. There is also this concept of independence logic by Jacob van Anen. So there are some trends in logic that may be of interest here, but I think that all this, at least from the point of view of science, is inside of classical logic. Yes. I know it's somewhat opposite maybe to the colleagues, but I think we want to have a debate. Yes. Mm-hmm. Okay. So,
I might say quite a lot on this topic because I know nothing about the ones at the end. When I saw the topic of the work of the panel, I thought surely it's as much about the role of AI in the development of logic as it is the other way around. And I also want to comment on what classical might mean. So 50 years ago, people started taking seriously the idea of giving semantics to non-monotonic reasoning. That's 50 years. In 1993, there was a book by Marek and Truszczyński called Non-Monotonic Logic, which is a masterpiece in my opinion. So that's 30 years. And Tomasz Jarmużek mentioned yesterday David Mackinson's book, Bridges with Classical Logic. That's 20 years. So 50 years, 30 years, 20 years. Surely that starts to count as classical now. So I still work with philosophical logicians who look with great suspicion at non-monotonic systems, even though they've been studied for 50 years already, and people who work in this area are quite comfortable with them. I want to this is not on the topic of the panel, but I have to say one thing. So yesterday I went to some really interesting talks on the history of Polish logic. And so here is my small contribution to that topic. So I mentioned the book by Marek and Truszczyński. I used to use this, I used to teach, and this was one of the background reading books. And students used to come and say, "Are you the Marek from Marek and Truszczyński?" And people came up to me at conferences and said, "Are you the Marek from Marek and Truszczyński?" And I had to explain, no, Marek is my first name. The author of Marek and Truszczyński is Viktor Marek. Marek is his family name. And yesterday, Viktor Marek was mentioned amongst the contributors or the descendants from the Polish school. So I have no relationship to Viktor Marek. However, the other author, Mirek Truszczyński, is my cousin, just out of, and we used to play as kids, and then I didn't know he worked in logic until one of my colleagues came back from a conference in the States, and his name was in the program. So he's my, actually, in the interests of accuracy, he's not my cousin, I'm his father's cousin. He's my nephew. He calls me uncle. So that's my small contribution to the history of. But imagine, by the way, the effect this had on my mental health. Imagine when you find out you're not even the best logician in your own family. This is. I also thought about, when I saw the topic, classical logic in complex decision making, I thought, well, of course there isn't any, so I don't know what to say. But then I thought, this isn't true. It's very, very hard. Of course, it depends what you mean by AI. So I mean, for us in academia, AI is the sorts of things that are talked about in conferences. And it's fair to say that the things that are talked about in conferences are at most toy problems. We all understand what the toy problems are, and we all try and find better solutions to these toy problems, but they're toy problems. You can't call them complex decision-making methods. However, in my institution, and in Britain generally, we have to justify our existence all the time. So people keep being asked, what is the impact of your work in real life? And it's very difficult, actually, to track the impact of one's work once it gets out into practice. You don't see the systems. They get embedded in much bigger systems where sometimes there's hardly a trace of what influenced that in the first place. I used to work on legal applications a lot, and I had some collaborative projects and some consultancies with some big firms, not lawyers. They were usually engineering firms. There's one French one, for instance. So they had a whole load of systems where air traffic control, building regulations, fire regulations, all kinds of things, where the sort of techniques we had developed were embedded within a much bigger system. There was hard, and they said, oh, we copied you and we integrated it and we integrated it and we integrated it. Sometimes they integrated it wrong, but still there was an influence. And when I said to them, oh, you know, you should go to these academic conferences, you should tell them what you've been doing, people are really interested in practical applications, you could go to a conference, they'll accept your papers. He said, why should we? He said, we're not in that business, you know, we make money, we have clients. Hey, you get more clients. He said, we got all the clients we need, we don't need any publicity. So I think it's as I say, I think there has been an influence. It always used to be said as well that AI is computer science done in universities that hasn't moved into practice yet. Once it moves into practice, it's not AI anymore, it's just software engineering or computing. And there's a lot of truth in this, or there used to be. Now, of course, everybody claims they're doing AI, even if they're not, but before it was simply absorbed. So I think there is classical logic or logic in complex decision making. And I wanted to say one other thing. So in the old days, there's different ways of using logic. One way is you write down everything you know in some symbolic language, and then you run a theorem prover over it to get deductions. This is one way. Another way is you have a model of some kind, a mathematical model, a structure, and you use logic to evaluate properties of this model. But in recent years, there's another way that classical logic is being used, and that's model generation, or SAT solving, or constraint solving. And this has been a massive breakthrough because one can build enormous constraint problems in classical logic or variations thereof. And modern SAT solvers generate, the solution is the model that you generate. And this is a different way of using logic, which is really practical, and I'm sure it's being used. So that's all I wanted to say. I'll say less on other topics.
So I'm pretty intimidated to be in a room full of logicians. So maybe I'll give a slightly general answer, which may not be like a direct answer to the question. So I started studying math because I didn't know what is math. And one of the things that I got interested in very early, like, are there algorithms to solving math problems? And obviously I took the courses in logic that told me no. And like the other thing that kind of attracted me to study math was that there was this kind of reductionist program or idea somehow implicitly taught to me that math is the language that encompasses basically everything, that you can reduce physics and other hard sciences to it. And the one sentence that probably I found later that captures it comes from Galileo, that mathematics is the language of science. And this somehow interacted at the time, this was in the 90s, with Kasparov being beaten by Deep Blue by a chess machine. So I guess today's generation has been inspired by some the AlphaGo Zero beating the Go players, but like this was already happening 30 years in the kind of pinnacle of human intelligence, supposedly being chess, right? The reason why I got into basically automated reasoning over a large body of mathematics, which, by the way, I've stolen from the Polish people because they had this Mizar system, which was really pioneering in formalizing a big body of mathematics back in the 90s, was that I thought this is really the way how to build universal AI. That the embedding of mathematics and implicitly, like all these other sciences that rely on mathematics, is like one good approach how to basically have universal problem solvers. And this, by the way, also was happening 30 years ago. Like there were these QED manifestos and QED workshops. Again, one of them was 30 years ago in Warsaw, organized by the Mizar people, with people like John McCarthy, where like the QED manifesto basically says, like, let's formalize all of mathematics and proof check all of mathematics on computers. And maybe the next step, once we have such a big proof checked database of math, that will allow us to build strong automated reasoning and AI systems on top of such huge database. This was before Wikipedia, by the way, like to some extent you could say before internet, like the building of the Mizar library started in 1989, right? Like, I guess like the question, the way it's asked is saying, well, maybe classical logic isn't particularly good for some kind of AI problems, but if you look at it from the other side, to me, like let's say classical mathematics with whatever foundations, like people today use set theory, type theory, higher order logic, some even use just first order logic to formalize mathematics, is really a very interesting substrate into which we may be able to embed all sorts of problems. And like to speak a bit more about this, like I think this really goes back to Leibniz, at least in my mind, who dreamt about like having this universal language and the universal kind of decision procedures for that language. Like here, this famous quote, let us calculate, right? Like calculimus. And at least what I say, and I'm now really risking it because I'm in a room full of logicians, to me, the best incarnation of the Leibniz dream is the symbolic logic, as, I don't know, probably done first time for real by Frege or somebody like Frege. And then, and again, this is probably a big jump, but I would say, at least in my mind, there is Turing, who basically creates this machine which is like a symbolic logic machine, like it's a machine that executes symbolic logic rules or instructions, and that allows us to start like implementing all these crazy algorithms, decision procedures, etc. And that's, by the way, the substrate on which everything is running today, not just Prolog or automated theorem provers, but large language models. Like the hardware is fully symbolically logical on which all of this stuff is today running at the bottom level on very seriously proof-checked, mathematically checked, tested, incredibly verified symbolic logic machines. Yeah, well, I'll probably stop here.
Okay, so, yep, let's...
So are we allowed to do a second round, or should we progress?
We have still 4 questions, so...
Okay.
Then you can summarize if you want.
Okay, so...
Okay, so, well, let's go then. After this first quite general question, but with many different views to this, presented by the speakers, to some more concrete, I think that we can just start with a comment of to the last question with the next when we next time give the microphone and the voice, and we will continue in the same order, but starting with the different panelists. So my second question is a bit more concrete. It's about the logical reasoning contribution to the development of algorithms of AI, and in particular in the areas like theorem proving and knowledge representation, and some other important things is to maybe to say something about the citability verification and correctness that we already heard something about it. So now maybe let's start from Professor Imroga.
Okay, thank you. In my opinion, as I already expressed in my answer to the previous question, I think the role of logical reasoning and logic-based knowledge representation is not really in providing working solutions, especially for decision-making algorithms. So if you think of I don't know, classifiers, large language models, decision-making AI models, typically you are much better off nowadays obtaining them via machine learning. There is a whole set of problems coming with that. First, in the first place, because they are black boxes. So there's typically no understanding how they work internally. You cannot predict well how they are going to behave. But if you want to have something like a working component, I don't know of logic-based solutions that are competitive, okay? So, and this is exactly because of issues like decidability, complexity of, let's say, verification, or the complexity of reasoning, of generating models, and so on and so on. It's just too high. As Marek said, basically what we do in research, especially in our community, is permanently dealing with toy problems. Whenever somebody tries to scale it up to real-life scenarios, like I have been trying to apply logic-based techniques, especially formal specification and verification, to the analysis of elections and voting procedures. And I know that Rajiv has been doing quite a lot of that. But at the end of the day, we can really apply our techniques to very, very simplified abstractions of the real application domain. And it does not scale upwards. So, in my opinion, the real question is not in what way logic contributes to the development of algorithms for decision-making and working AI, but more general, what is the role of logic-based solutions? And I agree with Marek that there has been probably quite a bit of influence, but the influence is not so direct, in this, not in the sense that we take some logical system, we take a decision problem, theorem proving, SAT testing, model checking, whatever, and we just put it in the box. We put the box in the environment and it does something for us. The role is much more subtle, but I think it's going to be more of a topic of the next question, so I'm finishing my answer now.
Yes, so the question was the contribution of logic to algorithms for AI. So let me start, well, as this remark that logic contributes to algorithms in general. Yes, it can be traced back to Claude Shannon and his observation that actually switching circuits can be organized according to the rules of Boole. Yes, and in algorithms there is direct correspondence between logic and complexity features, in particular the number of variables and the number of processors in parallel programming and so on. So certainly logic underlies algorithms in general, but in AI and especially in these LLMs, so it seems that the logic, the mathematical logic plays a role in the preliminary phase and in the verification phase, and what is in the middle is something mysterious, yes, with transformers and in the preliminary phase, certainly there is advanced mathematics that plays a role. Yes? So the MISAR system that was mentioned, that we will certainly talk about it more, it explores this Tarski-Grothendieck set theory. The Coq and lean systems that you know, this proof assistants, they are based on calculus of constructions and Carey-Howard correspondences. So there's really interesting advanced mathematics that underlies the systems. But what is going on in transformers? Well, I'm not expert, but my colleague who worked in databases and with much success, Paweł Parys, but this summer he starts investigation in LLMs in Santa Barbara with someone there, and so he also said that it's something that in fact nobody really understands how it happens that these transformers work so efficiently. So my opinion is, you know maybe is this theory of scientific revolutions of Thomas Kuhn. Yes, that there are these periods of accumulation, and there's this toy problems, and there are some periods of revolution that require a new paradigm. Yes, so maybe we are in the moment that we have to find some new paradigm for the logic in computer science. So maybe this is just this.
Well, I mean, for algorithms, I mean, obviously mathematics and logic plays a role in designing and algorithms. I wanted to address the knowledge representation part though. So there's more than knowledge representation. Well, first, what is it? So when I used to teach in I had a course, knowledge representation. To explain what knowledge representation meant in practice, I used to take the current knowledge representation KR call for papers in the first lecture and show the list of topics that for which submissions were solicited. And then next to it, I used to show the accepted papers, the sessions, not the detailed papers. Because this gives a quite good impression of what knowledge representation means in practice, rather than just imagining it. And again, as you would expect, there are topics which dominate and have dominated from the very beginning in AI and knowledge representation. Take one. events, action, change. This is constant, obviously a central topic. There's more to just designing some language. You have to think about, what is an event, what is an action, how do they compare? And one way of doing this is by reading what other people have written in philosophy and so on. And there's a very good exercise, which is to take writings in philosophy, say, and try to formalize them in such detail that even a stupid machine can understand. This is a really good discipline. And I used to try and make things wrong, because if the machine can actually execute what you've done, it suggests that you've done it in enough detail. And often the detail is what leads to a better understanding. So I'm counting logic as the development of logical expressions of theories, philosophical questions, and so on, but at a level where machines can execute them, so at least you know whether you've done it in sufficient detail. That's my contribution to that topic.
Yeah, so one quick remark on that. When I worked in the Netherlands, we had a PhD student who told me that he is dyslexic, and in every line he types in, he makes a typo. And he became an amazing formalizer in the COC/ROC proof assistant. Recently he got an ERC grant. He is one of the leading people behind the formal verification of Rust, like this modern, attractive programming language. So it's really, I would say, like in AI, there are all sorts of pendulum swings, all sorts of kind of fights between different factions. And I would say that the kind of general impression, like some people even started to call AI just large language models in the last, I don't know, 4 years, right? But like if you know the field more, then there has been like these other amazing revolutions happening in AI. One is, for example, the SAT solving, the conflict-driven close learning revolution that happened like almost 30 years ago, which was really an amazing boost for automated formal verification, model checking, etc. Like those things have been superhuman for like 20, 30 years. We can solve problems in math that we weren't dreaming about because they were combinatorially really difficult. And a similar revolution is this revolution of producing formally verified software, which I think especially in combination with the kind of statistical AI methods, or today, as I said, some people would say just AI methods, but or deep learning methods or language modeling methods. It's really becoming more and more possible to produce code which is simultaneously formally verified. So like 8 years ago, Amazon hired Byron Cook, and he created a really amazing team, the Amazon Reasoning Group. And for example, John Harrison, like 3-4 years ago, fully verified, and not just verified, but also optimized the assembly code that is running on your phone, on your browser, on your computer, which is doing like the secure communication between the browser and the server somewhere. So this is really formally proved in whole light down to the machine code level. And they are doing like really many such things today. So I think you can also look at it as kind of a necessary thing, because the LLMs are today so good in basically generating bad code or malicious code. So in some sense, like when people and even like some kind of AI safety people talk about like what do we do, not just with some crazy AIs becoming super smart and killing all of humans, but like with the kind of more mundane task of now the hackers got like amazing tools to produce all sorts of attacks and exploits. The answer is yes, like use this technology combined with the formal verification to speed up the formal verification and produce basically formally verified code that we will be running. And this has been like a long-term dream in the like formal proof, formal verification community. But today, if you are in the field, you really see that these things are speeding up like crazy, like not like both in the field of let's say verification of software, but also in the field of verification of mathematics, like the projects that are getting formally verified are really like research level advanced mathematics by people like Terence Tao, etc. So I'm very, I would say, bullish. Well, I have been for 30 years. But today, I would say, especially on these combinations of, let's say, learning-based and logic-based approaches.
Let us go to with the same question to our online speaker.
So, hi everybody. I apologize if anybody's already mentioned some of this, but the hearing gets worse and worse as the microphone gets further and further away from Wojtek. So, excuse me if somebody's already mentioned some of this stuff, but I wanted to pick up something that Wojtek said, where it basically said how good large language models are these days at apparently giving coherent answers. And from the little that I know about this, it appears to me that the biggest problem with equating large language models with AI is that they literally make up stuff. Right? At the end of the day, all they're doing is predicting the next word that's likely to occur in a sentence. And so one of the things that they suffer from is something called hallucination, where, as I said, they just make up stuff, basically. But one of the things that might be possible for logic to contribute here is to actually teach these large language models how to reason. And again, I apologize if anyone's already mentioned this, but there are actually companies out there right now that are generating data to feed to large language models. And the data is based on logic. So it's literally, there is a question from logic, and there is an answer which is logic-based, say in some sort of proof system. And I think sometimes it's even in systems like Ling. And so one of the things that we might be able to do is, by generating good examples of reasoning, we might actually be able to make these large language models better reasoners. And again, I don't know if anyone explored that at all along amongst the other speakers.
Thank you. And we already heard about black boxes, hallucinations, and mysterious transformers. So let us go to the third question, and let us ask about the related topics. So what about the logic methods to enhance transparency, interpretability, and explainability of AI? Maybe there is some hope with this. So let's start with Professor Niwiński.
Yes. So I've been looking around if there is some research in this direction. Actually, yes. There is some investigation on the computational power of LLMs, and actually, by some leading people in the US. There's work, so Dana Ungreen is contributing in particular, who was the founder of machine learning theory. So these people try to understand, this work is restricted to formal languages, but what is the actual power of these engines, like LLMs, compared to these models of complexity? Yes, so there are results that in general, they have the power of universal Turing machine, yes, so the Turing complete, yes, so in fact they can do everything. Otherwise, there's some limitations, there are some smaller classes. Maybe I would cite the questions that are posed by these authors. General question is, in particular, do failure cases anticipated from formal models occur in practice? Or what insight into the complexity of human language are offered by a characterization of transformer expressivity? Yes. So I think that generally, and in fact quite challenging question theoretically, is if the classical measures of complexity, yes, in terms of time, space, number of processors, if they are adequate to evaluate the efficiency of LLMs and of AI algorithms. Because it may happen that they are somehow, not completely adequate. Yes, so this is a question, I think, on theoretical side.
Yes, so I'm very enthusiastic about watching people develop methods for explainability and transparency. It's absolutely critical, but there's many different kinds of explanations. I remember when we did very complex representations of social security legislation. And our systems could explain why someone wasn't entitled to some social security benefit by quoting the legislation, saying, well, this is by paragraph 57B, this entitlement is only for these categories of people. You are not in this category of people, therefore you're not going to get this benefit. And a sociologist we had on the team said, that's not an explanation. You should explain why the social security legislation is like that, and therefore why this person isn't going to get. That's a real explanation. And there was a person from the civil service, from the Department of Social Security, who said, oh my God, that's the last thing we can allow. The whole point is having this legislation is so we can say you're not entitled to it because of paragraph 57B. If I now have to start telling you why paragraph 57B, there'll be a revolution and all kinds of things. So that's one observation. The second observation is sometimes explanations are traces of how something was done. And even if you run these large language models now and ask it, you get this endless stream of, oh, maybe it's this and maybe it's that, and maybe, but that's not. There's a difference between giving an account of how you solved the problem with justifying the solution at the end. If you read mathematics papers give you a proof, say. There's no account by the mathematician usually of how he or she came to get that proof. Judges give you a justification for their decisions at the end. They don't give you an account of how it was that they reached this decision. And I would like to see, I would really like to see further development of this. Symbolic systems on their own don't necessarily address this question. So in recent years, logic programming has moved from Prolog style implementations to ASP, answer set programming. Answer set programming, you write constraints and you get a solution, but you have no way of knowing where that solution came from. In fact, even as an experienced user of ASP, I sometimes am very surprised at an answer that I wasn't expecting. And I would really like the system to explain why this is an answer. Not how it obtained this answer, but why this was an answer that I wasn't explaining. So I think this is absolutely critical. This is where really logic can contribute, I think, in AI. Thank you.
Yeah, so on that, so I collaborate with algebraists and automated theorem proving people who basically for some 30 years now have been proving open conjectures in equational algebra. And Bob Verov, who is like the retired professor in the US, who is like the guru of this field, really gets proofs from Prover 9, which is his favorite theorem prover, which are 200,000 inferences long. So you can write. There are proof checkers which will go through these proof objects step by step, and they are independently verified in other systems, etc. So we have extreme security in knowing that these are really proofs of the conjectures. But like over and over, like this community of people have had troubles selling these proofs to the mathematicians, to publishing this in some journal of algebra. Because like, what do you do with this 200,000 long proof object? So like the mathematicians will ask you like, can you give us the idea of the proof? And there might not be any, right? Sometimes there is, sometimes like when they found the proof of the Robbins conjecture, the kind of legend is that they gave it to Donald Knuth, and Donald Knuth used his super brain to go through these tons of pages and told them, oh, look at this lemma, this is interesting. And based on that, they somehow recovered the human-friendly proof from this output of the automated theorem prover. But for example, for the four color problem, even though it has been safely verified like 20 years ago in the Coq system, so we do have this security, we still don't have a proof which would kind of satisfy the kind of explainability criterion. So that is really this area of, let's call it computer-assisted, or you could call it alien proofs, where we are getting thanks to these strong tools that we have, where we can verify, and that's really good because that brings the trust, but it doesn't really bring human understanding, whatever that means. So I think that this is really going to be very interesting. Like I have one project where we are not doing strictly theorem proving, but more like conjecturing. So we took the online encyclopedia of integer sequences, and we are running some kind of feedback loop between proposing symbolic programs that explain the integer sequences and just checking that these programs really generate the sequence, let's say up to 64 first terms. And like just today we have reached something like 135,000 quote-unquote solved sequences, where solved means that we can check it up to this number of terms. And like this feedback loop, because it's kind of self-learning, it doesn't learn from the human, it really starts from scratch, has already invented programs that we have really hard time figuring out whether they are a proper explanation for the intended meaning of the sequence of numbers, or whether they are some kind of alternative solutions that nobody thought about. So we are giving this to mathematicians to automate the theorem proofs, etc. But like it kind of demonstrates to me that like with these tools that we are today producing, we are really getting into some kind of design spaces which may not be totally friendly to human understanding, that may be like based on what the algorithms that we have can do, can solve, can learn, and that might not be necessarily corresponding to the human brain.
So let's ask about the explainability to our online panelist.
My turn? Yes. Yeah. Okay, so again, I'd like to come back to this idea that LLMs just make up things, and it's not clear that the explanations that they provide are in any sense meaningful, right? So one possibility that we might be able to do is to get these LLMs to generate its explanations, convert them into some sort of logical formalism, and then we use logic to check whether these explanations are in any sense meaningful. So I know some people that are working on this sort of stuff, and you know, these LLMs are now so good at generating logical expressions from natural language that it's actually feasible to check their explanations with some reason, you know, confidence. So again, I don't want to speak too long on this.
So, and last one to comment on these topics.
Okay, so I would like to go in a slightly orthogonal direction to what Josef and Rajiv have been talking about. So more on a general level, I would say, in my opinion, there's a lot of first of all, there's a lot of potential for logic and for the community of logic in computer science to contribute. My own research has been mainly, let's say, in the line of transparency. So formal verification, trying to model intelligent systems, multi-agent systems, come up with formalisms that allow to specify interesting properties and verify them. Of course, people doing this kind of research, they struggle with all kinds of obstacles, the complexity, computational complexity barrier, lack of expressivity, and so on. But there is a subset of the community trying to come up with more practical methods, typically based on some kind of abstraction, understood both informally and formally, to abstract away the irrelevant details and apply, let's say, for model checking techniques to verify actual neural networks. And there has been quite a bit of research on that in the last, let's say, 7 or 8 years. So this is one thing where I believe there is substantial potential. Another thing is explainable AI. So and there maybe even logic-based methods have higher potential than that. And in my opinion, it goes back to some remarks by Josef and Marek. So basically, how I would rephrase one of Josef's statements is that logic is good at providing concepts and conceptual structures, right? So Boolean logic as a provider of conceptual structures for algorithmics and computers, but also, you know, there's a lot of inspiration coming from logic-based methods, reasoning techniques and frameworks in computer science and AI to provide patterns of that are useful to come up with mathematical models and logical formal specifications of interesting properties, let's say, in multi-agent systems. Yeah? And then something, what Marek said at some point, that actually a very profitable exercise, and what people do quite often, is to go back to the research in philosophy and try to rephrase more formally what philosophers have come up with to describe and capture interesting properties and interesting concepts. And again, formal logic is very good for that, because on the one hand, it has clear semantics, it's well defined, whatever we formalize in logic. On the other hand, it's much more concrete than the philosophers stated, and much closer to how people try to understand and are capable of understanding than, let's say, pure mathematics, or even worse, a neural network, or the content of a large language model. So, in my opinion, there's a lot of potential to apply logic-based methods to XAI to try and come up with explanations. I think it was stated by both Damian and Marek that the current state of the art in XAI is very far away from that. But basically, so I try to follow the research in XAI as a kind of informed external observer. My perception is that they are still at the level of spotting correlations, statistical correlations, and then presenting the statistical correlation in the form of some kind of completely unintelligible map, let's say salience map or whatever else, which is no explanation at all. So regardless of whether you would like to have explanations the way a civil servant likes, or a sociologist likes, or just a man on the street likes, the current XAI methods don't provide any of that. And I think there is huge potential for us logicians and people in logic in computer science to try and provide that. There are some attempts, like works by Adnan Darwish I think he's in Canada or US, who, so his people, they try to come up with explanations of how a neural network works by means of Boolean circuits, or basically propositional Boolean logic. But this is not the mainstream. This is like, I mean, it's marginal if you look at the mass of XAI research. So again, my message at this point would be, let's stand up and try to engage in XAI, because I think we have a lot to contribute.
Thank you very much. So we have heard a lot of things about the past, about the present, something about the future, but maybe let's focus on the future now, and we'll go to the fourth question. And there are more and more autonomous AI systems around us, and a lot of ethical issues related with that. So let us ask our panelists about their opinion in this topic. Maybe now let us start with Professor Sekot.
When I saw the list of questions and I heard that we might have to do them in turn, my heart sank that I would have to be the first to speak on this topic. I have some opinions on this topic, but if I get going, I'll rant. Okay, I'm going to talk about ethical systems, ethical AI systems. You might have to stop me if I get too extreme. So I was invited several times to workshops and so on where people talked about ethical systems. Okay, so first, taking an ethical theory and trying to formalize it and run it computationally, this is a very good idea. I think this is good. But then to build a machine which is somehow ethically behaving, I don't even know what this means. And people keep claiming that they're going to do this. It makes absolutely no sense to me. When I retired, I announced to my department that I had solved empirically the problem of building an ethical autonomous car. And I had no theory for it, but I had experimentally developed it, and I could guarantee from observation that it always made the ethically correct decision, my car. So for example, that very morning, I wanted to go and buy some paint, and I got into my car to drive to the paint shop, and it refused to start. My car refused to start. And I got really angry, and then I thought, no, this is ethically the right thing. Because I could walk to the bus stop, it's not far. I could take the bus, it's not far, buy a can of paint and come back. My car is correct. I don't need to go anywhere. Of course, it couldn't explain itself because we don't have explainable AI. But still it made the right. And in fact, I've noticed it always makes the right. It doesn't go anywhere anymore, but it always makes ethically the correct decision. And I said this, it was actually a serious point. And I told this story to Jeff Horty, who's one of the people who work in this area whose opinion I respect. And he thought, first he laughed, and then he said, that's actually very deep what you just said. And I think it is. I don't know what it means. People say, look at my machine. It's making ethical decisions. Look, you can see it is. I don't know what that means. What is the danger of AI? So the real danger of AI, it seems to me, I'll demonstrate with this little story. So a few years ago, before the pandemic, a guy I was at university with, who's a lawyer, he's not a friend, but I knew him. He's a KC, King's Counsel, is a top kind of lawyer in Britain. And he sent me an email, and he said, oh, my son has just graduated from some course at Oxford, and in the summer, he and his friend downloaded some online tutorial on machine learning, and some Python package. And then they started experimenting with it. And then got hold of some financial data, and they trained it. And now they've got a system which gives advice on financial matters. And they've started a startup company, and they're making money out of this. But he said they don't really know what they're doing. So could they call in and you could give them some tips for further development? I'll buy you a beer. That's what he said. And I was scared and insulted at one and the same time. I was scared because I looked at their website, and their website said they were selling this stuff. They were selling it. It said they use advanced AI techniques. Notice no one ever says they use elementary AI techniques. They always say advanced AI. So they use advanced AI techniques, and they had clients who were using their system to make decisions about their own finances by two guys who downloaded some tutorial off the web and implemented it in a Python package and admitted themselves they didn't really know what they were doing. But their next system, they wanted my advice to make it better. And I was insulted because I thought he's a very famous, a very high-powered lawyer. What if I wrote to him and said, I've got a son who's got himself into some legal problems, and we kind of think this is a good case. Could you give him some advice? I'll buy you a beer when I see you. He wouldn't do it, right? But yet, you look at these systems, they're all selling advanced AI techniques, and people buy this stuff. I listen to the radio where they actually it's a sports station, and they say, oh, we use ChatGPT to predict the results of football matches. And they say, oh, this is so good, we can't compete with this because ChatGPT literally knows everything there is to know. So ChatGPT will tell us the results of this football match. And if it can't, then no one can. And the real danger of AI, it seems to me, are these people who sell this stuff, and people believe it. They believe it. there's no authority. There's no anybody can do this. But and then even today in the newspaper it was talking about regulation of AI. How is this going to be regulated? I mean, I don't understand this at all. And I had, and a few years ago, so I had a colleague. I understand why he did it, but he thought he might get money for research by building ethical weapons, honestly. And he didn't believe you could build ethical weapons. But anyway, he could get money. And in fact, he got to the very, very last stage, you know, of the review process. But in the end, he just got below the threshold where they were going to fund it. So what would an ethical weapon system, an ethical missile, what would it do? You'd send it off, and it would make an ethical decision about whether it was going to blow up a hospital or a refugee camp or something. It doesn't make any sense. It simply doesn't make any sense. And I'm in despair. I don't know what to say about it. And that's what. If I carry on, I'll just rant forever.
Oh, yeah. Well, I do interact with the AGI people. So one of their lines would be, well, would you trust the humans, right? Like some of them are really like heavy believers in basically the AGIs learning from humans. Like I'd say like if I kind of go back to the full question, not just kind of the ethics aspect, and it's also I guess connects a bit to what Wojciech was saying. Like there is a reasonable push, like for example, Clark Barrett, one of the best people in SMT solving, who has been at Stanford for a while now, maybe like for 10 years. He has built a relatively big group. Like last year, I heard like 5 talks from his students at a conference in Prague about verification of neural networks. So it's especially for, let's say, SAT solving, SMT solving people, like I said, like these systems are today really amazingly powerful. Like we can give to a SAT solver problems with, I don't know, millions of variables and still hope for good results, and similarly with some SMT, with some theory sets, etc. So it's not totally hopeless today to take some, not some trillion parameter neural network, but let's say something smaller, something scaled down, and try to do some kind of formal property verification of it with the logical tools. So that's kind of a start, but it's like Wojciech said, like this field has been there now for some, I don't know, maybe eight years. There is also, like, I would say, the kind of deep learning community is also not just singing this mantra like, let's build bigger and bigger, more and more layers, language models, and this will somehow become magically intelligent. I think that there have been like several interesting shifts when you really look at this field. So one big critic of it's funny because he's also like one of the big deep learning guys, François Cholat, who is the author of the Keras toolkit, which is heavily used in deep learning. Last year gave a really very critical talk at the AGI conference in Seattle about language models being stupid and unimprovable in all sorts of ways. And he basically started a program synthesis startup after that. So that's like one example of somebody in the field who says like fine, statistical machine learning is good, but maybe let's use it for building like more robust, more explainable, and maybe also more verifiable systems like programs, etc. And another example is like we had 2 talks at the conference I organized at AITP from people who do kind of physics, like AI and machine learning for physics, where, and again, I have seen multiple papers like this recently. You use neural network to learn, let's say, some kind of physical system, some kind of physical laws, but you add an additional objective or constraint to push that neural network to be of a particular shape, so that you can later extract algorithms from that, so that you can reasonably make it go towards something that is explainable later, and then maybe you can run it, maybe you can verify it, you can input it in some computer algebra system, etc. So, and like one other example, like I go to these AGI conferences quite a lot. Like these people are also much more into like this kind of software engineering approach to AGI, rather than just one big language model which will somehow magically learn it all, see it all. So they also try to really think about how to decompose the problem of intelligence, and then they get all these various components which may be to some extent inspired by the human brain or whatever. And because this is like white box, then it gives you more hooks, like more opportunities to put some criteria on the communication between these components, and possibly again require some formal properties from them. So that's on one side, like these various alternative attempts from the kind of AI or modern deep learning people. The other thing is this ethics. Like this question is more about like these like can we build systems which are ethical? And I guess I would get into a similar long talk as Marek did. So I do have a postdoc who is actually formalizing ethics with the intent to ultimately contribute to making ethical AI systems, and it's really hard apparently. Like to formally specify ethical criteria in a way that it gives us some good overarching theory according to which we behave. Like it's an interesting research topic, but it seems to be like I do formalization of math and the AI systems for that, and it's kind of very easy compared to these like murky things like what is ethics, how does this ontology of various ethical principles interact? So I think it's so hard that it's maybe not gonna happen, but I'm not sure.
So let's go with this question to Professor Gore.
So I'd actually like to agree completely with what the last speaker was talking about, that I think that asking, logic to contribute to ethical considerations of AI actually throws up more research problems for us. rather than anything else. I'm not an expert in this area at all, but I really think that you know, sort of a logic of ethics or something is not out there at the moment. So I actually think that this is throwing the problem for us to explore as researchers.
Thank you.
Okay, thanks. So I must say I'm inclined to disagree, which is nice because it's a panel discussion, so there should be some discussion. I mean, in general, I appreciate Marek and Josef's and Rajiv's point of view that it makes no particular sense at this point to talk about ethical AI because AI at this point it might change in some years, but at this point it's just a tool, right? I mean, or like a toolbox with various solutions. So a hammer is not neither ethical nor unethical, right? But in a more narrow sense, you can reason about the potential use of the tool and whether it can be used in an unethical way. And the particular feature of AI is that this is a very sophisticated tool. It's algorithmic. It's embedded in its environment of action because typically these tools are used online via internet, so on your computer, and they can be designed in a much more sophisticated way where some safeguards are included. And in order to provide those safeguards and understand them better and also try to validate them, logic can be very good. And in particular, the techniques that people have been using in formal methods for multi-agent systems are one good example. There is a whole zoo of logical systems that you can use to formalize various properties, concepts. You can come up with with ideas and formalizations of safeguards for AI solutions. So I think in the narrow sense, there is a good potential for logic-based solutions to ensure, or let's say, not to ensure, but to limit unethical use of AI solutions. And I just, to finish, I want to cite something that I heard a month ago at the ICHKAI conference, so one of the top AI conferences, and there was a presentation in one of the sessions when I liked very much what one of the speakers said, that AI is a dual-use technology. So in the technical sense, people usually use it to refer to technologies that have both military and civilian applications, but in a more general way, it's technologies that can have immediate applications to both do good and do harm. And his example was the impact of LLMs on how people behave on social networks, that it can be both beneficial, like making people more polite and kinder in interaction, but very often it's the opposite because of various reasons. Basically, the market works like that, and there is a lot of incentive for the big IT companies to inspire polarization and heated disputes and so on. And this is what very often happens when LLMs are included in the interaction. So, so it's a tool, but it's a very sophisticated tool, and one which has often very profound and subtle impact on how the society and how people behave and what they get from the interaction. But at the same time, because it's sophisticated, we can engineer safeguards into the behavior of the tool, into the specification of the tool, to at least tame some of the unwelcome behaviors, some of the unwelcome possibilities. And in my opinion, some of the work in ethics, especially formal ethics, via logical specification, can be useful in this respect.
Yes, so I think I agree with Wojtek, well, in the sense that we cannot ignore the problem. Certainly, well, this is a tool, and like hammer or knife, you can use in good or bad direction. But everything, even music, you can use badly. But in fact, the problem becomes important at in concerning impact of AI. So one problem is disinformation, is fake news and so on. I think that in addition to some control, as Wojtek suggested, we can think maybe of some positive tools. So one point is, of course, education. Yes, people and thinking, trying to understand. But maybe actually AI could contribute to develop some tools so that people could control somehow control the reliability of sources. It's already an aspect of construction of models that they give better results if they are trained on clean data. Yes, and so there are some companies that actually provide clean data, and it's profitable. Certainly the topic, the problem requires some attention and maybe some invention, and it's maybe not so interesting from commercial point of view, but I think that scientific community should think about it. Thanks.
Okay. So let us go with the final round of the part of the discussion, and ask an open question now. So, what is the personal view of our panelists in the role of the logic in the development of artificial intelligence? And let's start from Professor.
So for some 10 or 15 years, when I give my propaganda lectures, brainwashing people that they should be combining reasoning and learning, I put as one of the first slides a slide I have stolen from the Logic Comics book, where they have the picture of Poincaré and Hilbert as two angels sitting somewhere on the Eiffel Tower in Paris during the Mathematical Congress in, I think, 1905. And they are kind of quarreling, like these two best mathematicians of their time are quarreling about intuition versus formal logic. So I think Hilbert is saying something like, no one shall expel us from the paradise created for us by Herr Cantor. And Poincaré is saying something like, oh, this is all bullshit, you will kill mathematical intuition, mathematical spirit, etc. So, I think I can say after like some 20, 30 years of trying to combine these things, that the combination of like this thing, the symbolic logic and formal proof is really like one of the top achievements of humankind, at least to me. Like it's some kind of culmination of the process that started like with the basically invention of science, like Leibniz had all these dreams, etc. And it, as I said before, I strongly believe that this led to the basically development of computers and therefore AI. So in like the fact that we can do all these crazy things is very much thanks to having symbolic logic. But like again, like there is the other side. There is Poincaré. There are the people who very correctly say that logic is not enough for solving problems, right? Like you really very often need the intuition, you need to learn from the world, be it some kind of mathematical world or be it the real world, about the actual distributions, the patterns, etc., etc. And like these two things, they really interact in very interesting ways. Like the research that we do kind of always over and over shows that sometimes your intuitions are wrong. Like the history of science is full of examples where the intuition was wrong, like I don't know, some Newton versus Einstein or some quantum mechanics, which are very counterintuitive, but like you convince yourself by some kind of reasoning that these things are really like the proper world model, and then you push them back into your intuition, and these things go and go in various feedback loops, and that's how we progress, like how science progresses, etc. So I think, like I already said, that there are these pendulum swings also in AI, and you can, for example, very recently in the language modeling community, that you can almost see how they kind of stopped talking about the scaling, and now they are full of these chain of thought and reasoning models, like whatever they mean by reasoning. But it's like even that community is kind of getting oriented to some extent in this direction. Like maybe everything will not just go through the layers of the neural network, but it really needs to go through a recall of some kind of soft facts that will get written on some tape, which they call context, and then processed over and over, and these interactions today can really get very, very long. And if you try to solve math problems, it really resembles how you run, let's say, automated theorem provers today. So I think the future is kind of in the interaction of all these methods. Like maybe one thing to say about AI is that there is really a big spectrum of approaches. And for example, if you want, you can put yourself into the shoes of a guy who has been doing genetic algorithms and evolutionary methods for all of his life. And that guy may have a similar point as the neural people had recently, saying, well, if you give me enough resources, I will evolve not just a human brain or intelligence, but all of life from which intelligence will emerge. So there are like these ways how to get to intelligence or AI that are like becoming more and more prominent or more and more suppressed in the AI community. And like we don't really know what the future is. Like the Transformers made a big splash 7-8 years ago, but now it's kind of an old architecture, so it's amazing they are kind of still kicking. Like you could expect some new things by now. Maybe one last thing I would say is that even though logic is such an interesting object in like the history of humanity or human science, it's also emergent. Like it emerged relatively recently from whatever, right? Like from human reasoning, human communication, human language. And I could also imagine that logic will emerge in various ways. For example, with the subsymbolic methods. For example, a language model could decide and invent that following the rules of logic will be beneficial for its overall processing, for its overall problem solving, etc. And similarly, for example, for the evolutionary people, like you could kind of pull this all back to, for example, evolutionary methods. Yeah, that's it.
Thank you. So let us ask for some summary words from Australia.
So it's interesting that what the previous speaker said about, was it Poincaré and Hilbert discussing things. I believe that logic will play an important role in the future of AI, primarily as a way to keep these large language models, AIs, whatever you call them, honest, you know, in the sense that they have to make sense, whatever that means from a logical perspective. But I think the biggest problem that we're going to have is actually to convince the people who are building these large language models that logic can play an important role. So I'd like to tell a little anecdote. I was invited to a Darkstool seminar last year, and it was on proof theory applications. And while I was there, I noticed that in parallel with our seminar was a seminar on machine learning and AI management. And so I thought, oh, this is a great way to touch base with these people. So I went over there and said, you know, do you mind if I sit in on some of your lectures? I'm a logician from, you know, the other Darkstool seminar. And they said, yes, of course, no problem. And I got really excited because they talk about, you know, things like counterfactuals, right? And logical explanations and well-structured reasoning and things like that. And so I kept waiting for someone to say, oh, and of course we need some sort of logic behind this. And nobody did. And then when I finally put up my hand and talked about, well, these are all logical concepts that you're talking about, you know, counterfactuals and explanations and things, and they basically just laughed at me. They believed in total honesty that what they were doing was going to get them there, right? And there was no need for any sort of oversight or guardrails, as Wojciech mentioned, from, you know, any sort of logical reasoning. So I think we have a great future and we can contribute, but I'm not sure that the other side's listening. And the way that I see it is, I've talked to my colleagues at Monash here who work in large language models and reasoning. And what I think will need to happen is that there will need to be some period of time where we let them, you know, it's sort of like give them enough rope to hang themselves, and then eventually they'll figure out that, well, actually, no, you know, learning doesn't solve everything, and we do need some aspects of reasoning. So I think we have to wait.
Okay, so let's summarize.
So first, following up on Rajiv's anecdote, my own anecdote, some years ago I went to a workshop on social simulation and simulation of ecosystems, primarily because it was in Madeira and I love the place. But it was very interesting. And one of the talks was on simulating the savanna ecosystem to make sure that it satisfies some kind of resilience, robustness properties. And then, you know, to me it looked pretty much so my core research area is model checking of strategic logics. So basically modal logics to express action and strategies, strategic play, and what can come out of that. So I approached the speakers and told them that, look, that was extremely interesting, and to me it seems pretty much like model checking of strategic logics. And the response was, yeah, okay, that's very interesting, but look, I have to leave to catch the bus and catch my plane. So it was obvious that they were scared the moment I mentioned the word logic. So there are huge gaps between communities, and of course, yes, I agree, it's a big challenge to cross over. And in the first place, because most of the people on the other side, they don't want really to talk to people from other communities. But yeah, I think it's worth making the effort. And just very quickly summarizing what I believe where the role of logic in AI might be, I want to mention 4 elements. One is conceptual structures. So providing conceptual structures to think and talk and reason about AI systems in a clearer way than just, you know, hand waving and using natural language. Then, as an intermediate language, to import concepts from philosophy, especially formal philosophy, but also ethical theories, legal theories, and so on, because there's a lot of interesting stuff out there, and logic can be the intermediate step to formalize them better and bring them to reason about AI systems. Then, more technically, to specify, so basically formal specification and verification, formal reasoning about properties of AI systems, including engineering safeguards, which are clearly defined in order to prevent those systems from doing bad things, whatever the bad things are. And then the last one, source of inspiration for explainable AI. As a vehicle for generating explanations that would be more of explanations than whatever is out there now. So this is my personal view.
Yes, so as I have been trained as well mathematician, so in fact I don't distinguish really between logic and mathematics. So what is the future of mathematics? Yes, you ask a person on the street, so it is clear what is true and what is false. Yes, but we could say, well, for us it is clear what we do know and what we don't know, and also there's the future of mathematics that we can distinguish. It's not always the case, but I think better than in our context, what can be solved and what perhaps cannot be solved. Yes, it's of course a difficult question, but this is one point that also, well, what is trivial and what is maybe interesting or challenging is. So in this context, well, I come back to this idea of scientific revolution. Well, maybe this may be a remote analogy, but you know what was the role of Boole and Frege is for constructing the language of mathematics. So maybe the role of this large language models for natural language is somehow comparable. Of course, knowledge is not direct, yes, but it somehow shows that there is some mathematics behind natural languages. And if you look at the world, especially in terms of say information theories, that will be talked by Wojtek this afternoon. So when you just look at some correlations and some entropies, so you see that in fact the natural language, which so as a student, so it's fuzzy, not precise, something not interesting. But in fact there are many interesting, perhaps connections, interesting, say, mathematical content in it. So maybe this is the role that LLM plays. And so in terms of this theory of revolutions, so we should expect that some new paradigm will emerge. And I think that maybe actually this paradigm will somehow synthesize logic, mathematics, maybe philosophy, physics, that maybe it will not be focused in traditional understood discipline, but will be somehow more, more large, yes, more comprehensive. So maybe this is my word.
In my professional career, I've been asked a few times to make a prediction, and without exception, I've been completely wrong. So my opinion doesn't count here. When I was asked to join this panel, I prepared by because I don't know anything about current AI or future AI, but I know people who do. So I have several former students who work in the area. One in particular was very heavily involved at the beginning of DeepMind, before it was built, before it was bought. But he made a career move not to join in with them, which was anyway. He's interesting because he ran an AI company. He did a PhD quite late, so he already had an AI company. But he trained as a philosophical logician. And even when he was building AI systems, he still wrote papers on philosophical logic. And when we did the PhD, he was a PhD student, but he was very independent anyway. So the PhD was on formalizing Kant in order to build a perception machine. But now he works at DeepMind, and he works at DeepMind in the very group which combines logic or reasoning with deep learning models and so on. So he's in one of those teams that participates in maths Olympics and so on. So I asked him. I said, what? He's been telling me over the years what he works on, and I couldn't really understand. I couldn't understand how you teach a machine logic by giving it lots of examples, and it learns to do proofs, for instance. Anyway, so that was one preparation. I asked him, and then the other preparation is I started to play with some of these current systems to see what kind of reasoning tasks it could do, and it was quite surprising. So I gave it problems formulated in natural language, told it that I had a formal theory of my own, and I wanted to see how intuitively it would solve this problem. And then I corrected it occasionally and said, no, why isn't this a solution? And anyway, this was very interesting. Then I also gave it a formal theory of my own and said, here's an example, formalize it. And it did a really quite impressive job. And I told this to my friend and colleague and former PhD student, and he said, what you'll find, I think, is that they're better at formalizing than at executing. So I taught it to execute this formalism as well, and it got quite good. But the most amazing thing of all is the best thing I ever read on ethics for machines is in a book by Michael Frayn called The Tin Men from 1964. It's a joke, but it's a parody, it's funny. One of the departments in this book is an ethics department where they build ethical machines called Samaritan machines. And the whole book is, the description of these Samaritan machines is, they place these machines in a life-threatening situation, a rubber boat which is sinking, and then they see if the machines will make ethically correct decisions about sacrificing themselves or not, and so on. And it's hilariously funny. Everyone who's interested should read this. But just for my own interest, I thought I'm going to reverse engineer these machines. I'm going to build these machines and see if I can make them do the reasoning that he suggests, and see what happens if you put 2 of them or 3 of them or 4 of them or 5 of them in a rubber boat, and see what happens. And it's quite a lot of work to formalize it enough so you can build a simulation. But I tried it on not on the Gemini LLM. So I told it, in this boat there are the following agents with the following characteristics. This one is selfish, this one cares about other people more, this one will value someone else's life more than its own. And then I didn't say, what should it do? I said, what will happen? And it gave a little story. It was exactly the same simulations that I was trying to build for my own amusement. It's a really good game. You should try it. There's no logic in here at all. So anyway, I asked my friend. I said, in this panel, so he works on logic and these deep learning models. And I said, one of the questions in this panel is, what is the future of logic in future AI? And he said, that's a really good question. If you find out, could you tell us? Because we don't, so they don't know. He says, I don't even know if there is a role. And he's a logician, and he doesn't know if there's a role. And he works in this area. So that's all my contribution is. Who knows? I don't. Who knows in the near future, let alone in the far future? So that's all I have to say on this matter. Yeah. Oh, you've done.
So thank you very much. So we finished the main part of the panel, but as planned, we have still some time to the questions from the audience, if there are volunteers on the side, on the audience side, and then on the panelist side. Yep.
Okay, so I don't really like panels, but I like to ask questions and I like to attack people. So my name is Leon van der Torre. I worked in Logical for AI for 30 years. I think well, as Wojtek said, some of these things can maybe be clearer if we see AI not as a branch of computer science, but as a branch of philosophy. Because this is what it has for a long time been, and I think it's still like at least a merger between philosophy and computer science. And then if we see it as a branch of philosophy, we could actually say, okay, ethics is a branch of philosophy, AI is a branch of philosophy, and ethics of AI is a branch of philosophy. So I was thinking a bit about philosophy while listening to all these computer scientists. And then I was going back to the 90s. And in the 90s, I was working with David Makinson. And David Makinson was working in philosophical logic. And David came to me and he said, the problem in philosophical logic is that some people give too much value to logic. So they say, because there is AGM, and I love AGM, right? It's one of the theories David is famous for. And now we understand everything about theory chains or belief chains. Or he said, because of KLM, because of this non-monotonic logic, and now we understand everything about common sense reasoning. And this, of course, is not true. I mean, the role of logic is not this. There is a misunderstanding, a misconception about the role of logic. And I said to David, I work in AI, and in AI it's worse. I mean, in AI, you don't believe what's going on in logic in AI. And so we found each other. We were hanging out together. We were talking about how to solve this problem of the logic in philosophy and the logic in AI. And we came to a solution which is not so far from what Wojtek said. We said, because we said we need a metaphor. We also developed logics, but first of all, we need a metaphor for people to understand what the role of logic in philosophy and the role of logic in AI is. And it's not like in computer science. And so the metaphor we came up was a secretary. So logic is like a secretary, a good secretary, a very efficient secretary. And secretaries are very important. So it's not, we didn't invent this because we wanted to say something negative about secretaries, the opposite. I mean, if you have ever been the head of a department of computer science, you know that the secretary is very important, maybe the most important person in the department. So logic is like a secretary. This is what we thought. And the rest, like input-output logic, I will talk about this tomorrow. This input and output is because we were thinking about logic as a secretary. And I mean, I really like this book about David Makinson, which Sven Ove Hansen and Gernot was put together. And I think it's really insightful to see his development, because in the 80s, of course, he was started with logic, and then like Dov Gabay and like we do in argumentation, we say we have to add stuff to logic. But at some moment, David came to realize that if you take logic and you take all the stuff we add to logic, maybe the relation between the two is a bit different, and maybe we should be a bit more modest about the role of logic. Now, of course, people working in neural networks should also be a bit more modest about neural networks, and people working in many formal methods should be more modest, but I think this is my view on the role of logic in AI.
Thank you for the maybe more comment than the question, but do any of the panelists would like to answer? Yeah, please, a short answer.
Yeah, so just adding my own metaphor. So whenever I talk with my students about the role of logic, my view is logic is a language. Not in the sense of mathematical language, but just like, you know, natural language. And the role of a language is to say things, to tell stories, if you like. So, so it also, I agree with Leon that the role of logic is to serve. It's not to be the like first-class object in the neighborhood, right? It's to serve the disciplines around to I don't know, communicate better, to integrate better, to make more sense out of what's going on, and so on. So maybe it's not so far away from the role of a secretary, especially a Dutch secretary. Because in the Netherlands, secretaries are extremely important. So I think that explains some of Leon's statement.
Thank you. So I know that we have a second question.
Good morning, and thank you for this nice debate. Well, I have a question concerning an emerging technology called neurosymbolic computation. Namely, this is a new paradigm integrating some symbolic artificial intelligence and symbolic logic. Okay, indeed, there is still work for logicians in the realm of sub-symbolic computation. Indeed, there are people using logic to integrate systems of artificial neural network to obtain better advantages from a technical perspective. Amazon is using currently a technology like this. So what they are doing now in the paradigm of neurosymbolic computation is manipulating neural networks as belief bases. Now, what do you, first of all, what do you think about this specific field of application of logic? Okay.
Volunteer from our panelists? Tool. Tool. Yeah.
I'm not sure I fully... So is the question like what we think about neurosymbolic methods? Or? Yep. So I really hate that name because I think neural networks are just one statistical machine learning approach, and there are many other statistical machine learning approaches. And I understand why people started to use that, but I think it's kind of by definition excluding a lot of interesting research in machine learning. Like just to educate the crowd a bit, like there are interesting symbolic machine learning methods that may be resurfacing today in combination with statistical machine learning methods, like inductive logic programming is one. Like actually, my first experiments with machine learning were using inductive logic programming. So that's just an aside that, like, I think people should be, in general, talking about, let's say, combining, let's say, learning and reasoning, or learning and logical methods. And if they want to go into statistics, they should speak about statistical and symbolic methods rather than, or symbolic and sub-symbolic methods, rather than exclude everything else than neural in this concept. To get to the actual questions, well, I have been building systems that combine like some kind of statistical machine learning and some kind of reasoning systems, like automated theorem provers for like 20 years now. And it's really like if you take for example, a big database of mathematics with some implicit curriculum of easier and harder problems, then the feedback loop between solving the problems using some logical reasoning methods, like some automated theorem theories, and the learning of the guidance, like whatever it is, like whether it's a decision tree, whether it's a neural network, whether it's some simple logistic regression, is extremely powerful. But we have really known this for like 10, 20 years now. Like this is not a news. The field itself, like, is very interesting in the sense that, like, we do get these curves which are plateauing, like the reinforcement learning curves typically, and in some cases we are getting curves that are slightly more linear, so we don't get so much of the plateauing effect. And I would say the most interesting stuff is the research into, like, how to combine these methods, for example, to do some lemma discovery, some concept discovery, etc., to really push, let's say, some reinforcement learning loop into like the crazy dream, proving by itself the Fermat's last theorem, if we talk in mathematics, right? So you give it the axioms of set theory or some number theory, etc., and now you are watching, like, this feedback loop between the problem solving and the learning, and today it plateaus relatively early. But, like, what are the things that we should be doing to make it not plateau, to really kind of make it take off and to go into these things where it goes much beyond some math Olympiad problems, for example?
I come back to this Leon's question. I like this metaphor with secretary, that is not the most important person. But from time to time, there comes a moment when secretary becomes crucial. And so I think that in logic is the discovery of Gödel and Turing is of this incompleteness and compatibility. There is a phenomenon that is interested, whether you are interested in logic or not, but there's some important discovery of human knowledge which you could not discover without logic. Yes, I think that that maybe we are some moment that logic may have its moment of importance.
Thank you. I had some signals from organizers that we have time for one last question and maybe one or two last answers. So,
my question is a continuation of the previous one. So how do you think, how far the system of proof checkers are promising today in the context of large language models? So it means, for example, in Białystok, Poland, there was a system MISA and other proof checker system, but we know that in the future, large language models are more efficient to imitate mathematical reasoning. So can we say then that mathematical reasoning is just statistical? How do you think?
Do we have?
Or maybe Rajiv, please.
Maybe, do you want to answer, Rajiv? No,
I can quickly
okay.
offer some comments. So as far as I remember, theorem provers like Mizar, they also have a very important role of proof checkers, and I imagine that at least in this respect they can still be important, especially in the light of what some of the panelists mentioned. So problems with LLMs making up things, so-called hallucination and so on. So if you want to make sure that the proof produced by an LLM is a real proof, you probably need some external technology to verify that, and probably that's the best that we have at the moment. So hopefully they are not going to become obsolete. I don't know if somebody wants to.
So I think like if you want this kind of self-improving system, then like Wojciech said, like the formal proof is really an extremely good signal, right? Like you like basically, I'm tempted to say that no other field but for formal logic has such a strong signal about correctness. It's kind of qualified because there are better proofs and worse proofs. And so, for example, when we do this, we need to decide if we get 100 different proofs of some problem, which proofs shall we learn from? Like, shall we train the LLM or the neural network from only the shortest proof, for example, or shall we have some other criteria for selecting the proofs which we will learn from? And so that's one thing, like the interaction between the statistical system that proposes how to guide the inferencing, how to guide the proof, and the kind of confirmation that comes ultimately from the proof checker is really extremely powerful. Like it's hard to see any other domain where you can have this level of autonomous systems and self-evolving. Like today, when people train, for example, Gemini or OpenAI trains their systems to solve these Math Olympiad problems, it's not clear how this was done in particular. Like there are no papers. Like last year, what DeepMind did to get the silver medal in Math Olympiad was actually a formal system, a system which wasn't invented by DeepMind. These systems have existed for like 10 years, but they kind of focused it towards the Math Olympiad problems, which actually runs a formal system guided by some neural network. So in that case, we really did have the formal guarantee that the proofs produced are formally correct. Today, with these two results by DeepMind and OpenAI, you really need to rely on human judges, and it kind of doesn't scale, right? Like this year we had 2 or 3 solutions like this, but next year we will have 1,000 solutions like this. Next year everybody will train their own DeepSeek, Gemini, whatever. Like these things are becoming like easy, and who will grade these systems? There will be a crisis next year, and how do you scale this to research level mathematics? Like if you want to have an autonomous agent that goes into solving a hard mathematical problem, how do you decide that it really kind of made a proof of something rather than fooling itself? So you can kind of have some heuristic methods, but the formal proof is really the strongest guarantee of these things.
So maybe Professor Gore, maybe you want to add anything to the answers? It is quite hard to volunteer being online. To the questions from the audience that we had, and make some summary. Okay, so I will repeat the question to Professor Gore. Do you want to add something to the answers to the questions from the audience? It is not easy to volunteer being online.
I think there might be a problem with the connection, because it seems like...
it seems like it's almost... Yeah, so...
It's far away.
Probably we have lost the connection, at least partially. So. So yeah.
Sorry guys, I missed that. What's happening?
Raj, the question is if you would like to make some summary, to add something to the discussion, because you are online, so we would like to give you opportunity to say more.
No, I'm fine. I'm happy with what I've done so far.
Because for a moment we lost the connection, so okay. So we are getting closer to the end. Let me say something using my, special position of moderator. So I'd like to say that at the beginning I asked some provocative question, as you remember, about employment and AI. But let me make some reasoning, and you can, make an assessment if it is logically correct. Yes, AI is a collective name for some set of software, some programming. Yes, but any software is created in a mathematical environment. I think that the premises are quite good. But any mathematical environment is ruled by logical principles, isn't it? It is, yes. So it means that if we think about theoretical level, not about application level, the conclusion is that logical principles always control AI at the very atomic level. It can be classical logic of some order, as in most cases it is, or non-classical if you consider some non-classical mathematics. But always at the basic level, AI cannot escape logic. This is my conclusion.
But you would need to prove some transitivity axioms.
You see, okay, sure, this is a good question, but this is a question about logical system we consider. So again, we must ask logicians, yes? If the implication is transitive, or it is not, yes? Of course, we can ask ChatGPT what ChatGPT thinks about this problem, but it can only think something that can be found in the opinions of people, yes? Particularly logicians, I think. Okay. But it doesn't mean that, look, this is another problem. Always doesn't hold. Where is the negation and quantifier? But this is again a logical problem, yes? Not always, or always not, yes? Okay, so thank you very much for the participation in our debate. We are very happy that you agreed to take part. Many new things here happened. I think that we should try to prepare some report at the end from your opinions. They are unique and they can be useful to the general discussion about the role of logic in AI. I think that we must consider this opportunity. Thank you particularly to Rajiv Gaur. Thank you, Raj. You are in Canberra, one of my favorite cities in the world. I know that now you have, what time is now in Canberra?
It's 8:30 at night.
Oh, you see? So have a good, let me say, evening, and thank you very much for your participation. And thank you, people who are here.
Thank you very much, Thomas.
It was nice to hear you. Thank you, all the audience for patience and for your participation too. Thank you very much, and bye-bye. The debate is finished.